When we have a linear model, we can assign meaning to that model. That is, we can give it an interpretation. So a function used to describe a real-life situation is a model. We have an input variable. That's the variable that's usually in the role of our x. And we have an output variable that's usually in the role of our y. We call the input variable the independent or the explanatory variable. We put the independent variable in the first column of an input-output table. We put it on the horizontal axis on the graph. The output variable we call the dependent variable or the response variable. We'll put that in the second column on the vertical axis on a graph. And usually there's some sort of a notion of we have some sort of control of the value of the independent variable. We choose the value of the independent variable, and then we see what happens to the dependent variable. In our model, we have an independent variable or explanatory variable, a dependent variable or a response variable. We think of the output as somehow responding to the input. When we have a linear model, its equation is a linear equation, and we'll usually write it in slope-intercept form. We've seen slope-intercept form before, written as y equals mx plus b. We can also write it as b plus mx. Remember, order doesn't matter in addition. Addition is commutative. So we can write the constant term first or the slope times the variable term first. We can also write this in function notation. Again, variable term first and then constant term, or constant term and then variable term. In real life situations, often we will find that our intercept, our b value, is some sort of a starting value. So in those cases, it often makes more sense to write the constant first. It doesn't matter what order these terms are written in. The slope is always the number that's multiplied by the variable. And then the intercept is always the number written by itself. In a model, the slope will represent the rate of change, and the intercept will represent the starting value. That is, the value of the dependent variable when the independent variable is 0. So that was a bunch of vocabulary. Let's see an example where we apply all of that vocabulary. So in this example, water is added to a swimming pool so that W, the number of gallons of water in the pool, after t minutes has passed, is given by W of t equals 15t plus 8,000. So our independent variable, recall, is the input. So it's the number we're putting into the function. So our independent variable is t. And what does t represent? So it's t minutes have passed, right? So t is the time for which we've been adding water, and we're going to measure the time in minutes. Remember, when a variable represents a real-world quantity, it has to have a unit associated with it. Our dependent variable then, so the dependent variable is the output, which will be W in this case. W represents the number of gallons of water in the pool. So W is the water in the pool in gallons. So T, our input, is the time that we've been adding water. W, the output, is the amount of water in the pool. Next, we'll identify the slope and the intercept. So the slope is the number multiplied by t. So in this case, our slope, m, is 15. The slope is the rate at which the output is changing relative to the input. In other words, it's the amount that the output increases, since in this case it's positive, so the output is increasing. It's the amount that the output increases each time the input increases by 1. So the output increases by 15. So the amount of water increases, increasing because our slope is positive. And we're going to say at a rate of 15, that number is the slope. And then we'll say the units of W, gallons, the word per, and then the units of T, minute. So the two units we just used were the output units per the input units. That means we add 15 gallons every time 1 minute passes. The amount of water increases at a rate of 15 gallons per minute. What about the intercept? So the intercept is the number that's added on. So in this case, B equals 8,000. B equals 8,000. That's the starting value of W. So W is the amount of water in the pool. So the pool contained 8,000 gallons of water. So W was 8,000 when we started, right? When we started adding water. So when we have an equation for a model, we can just look at the equation, and that gives us information about the situation. We can also use the equation plus algebra to answer more questions. So we can say how much water is in the pool after 10 minutes. So how much water? That's a question about the value of W. And after 10 minutes is giving us information about the value of T. So we're given the value of T and asked to find W. So how can we do that? Well, let's plug in the value that we know for T. In particular, we were just told that T is 10, right? Notice the units in which we were given the value of T matched the units of the variable T. Okay, so we were given the value of T and asked to find W. So I'm going to copy my equation. And I'm going to omit the function notation. I'm just going to write the variable W is equal to 15 times the value of T plus 8,000. And now we were told that the value of T was 10. Oh, we can just do that arithmetic. So 150 plus 8,000 is 8,150. After 10 minutes, the pool contains 8,150 what's? Gallons. We just found the value of W. So our answer has the same units that W has. Okay, let's see another one. Suppose we want to add water until the pool contains 86,000 gallons. How long will this take? So the pool contains 86,000 gallons. That's telling us W is 86,000. And then how long? That's asking us a question about T. We're given a value of W and asked to find T. So again, we take our equation, which was W equals 15t plus 8,000. And now we're going to plug in our known value of W, 8,600, and leave t as a variable. And now we're going to take a second and look at what we just wrote. Because in what we just wrote, we have t with arithmetic happening to it, right? T is not by itself on one side of our equation. Here it is. In order to find out what the value of t is, we need to use algebra to get t by itself. So this is a two-step equation. We need to solve this. I'm going to rewrite this with the t on the left side. So 15t plus 8,000 is 8,600. I'll subtract 8,000 on both sides. So I'm left with 15t equals 600. And now we'll divide both sides by 15. And we'll get t equals, that's going to be 40. So how long will it take? We found t equals 40. This will take 40 minutes. And again, we just found the value of t. So our answer has the same units as t does. Now, you will notice that in part C, the math was a lot easier than in part D. Right? In part C, we just had to plug in and do arithmetic. In part D, we had to solve an equation. Why? Well, the difference was in part C, we were finding the value of the dependent variable. In other words, we were finding the output given the input. On the other hand, in part D, we were finding the input given the output, which is kind of backwards from the usual thing we want. And so it requires more work. Now, we didn't need to know that in advance, because when we plugged in what we knew and looked at the resulting equation, we could see that in part C, we just had to work out the arithmetic. In part D, we had to solve a two-step equation. We don't need to know that in advance. We just need to look at what we've written. Let's see one more example where we're giving interpretations to our equation. In this story, one year, a first grade class grows a plant as part of their science studies. The function h of t equals 2/3 t plus 3/4 gives the plant's height h in inches, where t is the number of weeks since the first day of the school year. So t, the number of weeks since the first day, is our input variable. This is our independent variable. The height h in inches is our dependent variable. How tall is the plant on the first day of school? Right? On the first day of school, that's when the number of weeks since the first day of school is 0. How tall is the plant? That's asking us about the value of h. There are two ways we can answer that question. One, we can plug in t equals 0 and find the value of h. So when t equals 0, we'll take h of 0 is 2/3 times 0 plus 3/4 equals 0 plus 3/4 is just 3/4. So that's one way to do this. Or we can notice that this is asking for the starting value. So we can notice that this is asking us for the intercept, which we can see in the equation is 3/4. Either way, The answer to how tall is the plant is the plant is 3/4 inch tall. So on the first day of school, the plant was 3/4 of an inch tall. Next, identify the slope, it says. So the slope is the number that's multiplied by the input. In this function, we have the slope m is 2/3. The slope represents the rate of change. So the plant's height is increasing because the slope is positive. When a plant's height increases, we'd say that the plant is growing. So the plant grows at a rate of, we give the value of m, 2/3, and then we'll give the units of h, and then we'll say per, and then we'll give the units of the input variable. So t is the number of weeks. So the units of t are weeks, 2/3 of an inch per week. So the slope is the rate of change. In this case, the slope tells us how fast the plant is growing. Okay, and again, we can use this equation to answer questions. So, how tall is the plant? That's asking us for the value of h. After 3.5 weeks, that's telling us the value of t. We're given a value of t, namely 3.5, and asked to find the corresponding value of h. So we'll plug that into our equation. H of 3.5, that'll be 2/3 times 3.5 plus 3/4. Okay, let's use the calculator for this. On the calculator, we'll start by saying 2/3 times 3.5 plus 3/4. And we get this awful decimal. So since this is not a nice decimal, we'd like to give it as a fraction. I press the math key and choose convert to fraction. 37/12. 37/12 of an inch tall. That sounds weird. I'd like that as a mixed number. There are two ways we can get a mixed number. If you have the most recent version of the calculator firmware, you can convert that 37/12 to a mixed number by hitting alpha y equals and choosing the third option, which is the convert to a mixed number option. If you do not get that menu when you hit alpha y equals, then you can instead say, well, looking at the decimal, I can see that the whole number part is 3. So I'm going to subtract off 3, and I'm left with 1/12. So either way, the result we get is 3 and 1/12. So we find that the plant is 3 and 1/12 inches tall after 3.5 weeks. We can also answer the question, after how many weeks? So this is asking us for t. Will the plant be 10 and 3/4 inches tall? This is giving us a value of h. So we're given a value of h, namely 10 3/4, and asked to find a value of t. We plug our known value of h into the equation, and that gives us 10 3/4 equals 2/3 t plus 3/4. And now looking at this equation, we see that our variable is not by itself, so we need to solve a two-step equation here. So I'm first going to rewrite it with the t on the left. So 2/3 t plus 3/4 equals 10 3/4. We'll subtract 3/4 on both sides. You can use a calculator for this subtraction if you like. 2/3 t equals 10. We'll divide by 2/3, and we'll get t equals 15. So it takes 15 weeks for the plant to be 10 3/4 inches tall. Notice that working with this function was just the same as working with the previous function, except we had to use a calculator because the arithmetic was a little bit harder. So either way, no matter what the numbers in our function look like, we can interpret that function to describe the slope and the intercept, and also to answer questions about one variable given the value of the other variable.